In today's video, we'll be doing a full unit review for Unit 1 of Precalculus. There's only 10 more units to go, and this video will be very surface level, so I suggest you still do your own studying and practice outside of this video. In our first question, we need to determine if the function is continuous. So this function is clearly a rational function. And if you know anything about rational functions, the type of discontinuity normally associated with these functions is an infinite discontinuity. And these discontinuities are formed by asymptotes, and a rational function has asymptotes, a vertical and a horizontal one. So that makes sense. So make sure you keep that in mind when we're solving this question. So let's go ahead and find the asymptotes for this question. To find the asymptote, we want to set the denominator equal to 0. If we set this equal to 0, we have a quadratic being equal to 0. We need to go ahead and factor this quadratic, so we'll use the AC method. We need to find what numbers multiply to -9 and add to -6. You need to be able to do this quick, especially if you're in AP Precalculus, because this is a common thing you need to know on tests. So -3 adds to -3 plus -3 adds to -6, and -3 times -3 multiplies to +9. So we'll be using -3. So we're going to go ahead and replace -6x with -3x. And then we're going to go ahead and factor. So we're going to group. We're going to take out an x. We're going to get x minus 3. And we're going to take out a -3. We're going to get x minus 3. Make sure these two match up before you do anything else. Then you want to group these two terms, you want to group these terms that you factored out into a parentheses. And then put these same ones in their own parentheses. This is the same as x minus 3 squared being equal to 0. If we set x minus 3 squared equal to 0, we can square root both sides to get rid of the square. And we'll get x minus 3 being equal to 0. That means our vertical asymptote is at x equals 3. So that means we have an asymptote at 3. And since we have an asymptote at 3, that means we will have an infinite discontinuity at 3, because remember, we are dealing with asymptotes, and asymptotes mean infinite discontinuities. So let's go ahead and look through our answer choices and see which one is correct. A is mentioning a jump discontinuity at x equals 0. A jump discontinuity is, for example, from like point to point. This would be a jump because it literally jumps. But we don't have a jump discontinuity in this rational function. We don't have any of that. We have an infinite discontinuity, so A is incorrect. B says that there's an infinite discontinuity at x equals 3, which is true. We just went over that. We just solved that. C is wrong. Rational functions are most of the times not continuous, so C could not be correct. And D says that we have a hole at x equals 1 and an infinite discontinuity at x equals 0. Well, we know our infinite discontinuity is at x equals 3, so since this is false, this whole answer will be false. And we don't have a hole at x equals 1 because we don't have any like factors canceling. For example, a removable discontinuity is when you have a factor that cancels in the numerator and the denominator. So if we had like x minus 1, x plus 3 divided by x minus 1, since we have an x minus 1 on top and bottom, these would cancel. And that would mean a hole at x equals 1, because you'd want to set this equal to 0, and we'd get x equals 1. That would be a hole at x equals 1, which is a removable discontinuity, or a hole discontinuity. We don't have that here. We have nothing canceling, nothing factoring, nothing like canceling from the top and the bottom. So therefore, D is wrong because there literally is no removable discontinuity anyways. So that is how you do this that is how you solve this question. Let's go ahead and take a look at our next question. So we need to find the average rate of change for this function over the interval -1 to -3/4, and we have our answer choices right here. So if you know anything about average rate of change, the formula is f of b minus f of a over b minus a. You need to know this formula. It's very important, and they're not going to give it to you on a test. I have a video on this in case you're unfamiliar with this topic. It'll be in the description down below. So let's go ahead and find our f of b, f of a, and b and a. Your b and a are freebies. They're given to you in this interval. The first number is a and the second number is b. So let's go ahead and find f of a. To find f of a, you need to plug in a for x, because f of a is the output for a, which is like the y value. So if you plug in -1 for x, we'll get -1 over 1, which is -1. So our f of a will be at -1. To find our f of b, we'll do the same thing but with -3/4 because our b is -3/4. So we'll get -1 over -3/4 plus 2. 2 is the same as 8 over 4, so I'm just going to rewrite this as 8 over 4. So we'll get -1 over 8 over 4 minus 3 over 4. If you rearrange this, you'd get 5 over 4. And you need to know copy dot flip. So you're going to save this first number here, which is -1. We're going to add a dot or a multiplication sign, and we're going to flip this fraction, this 5/4, into a 4/5. And we're going to go ahead and multiply these, and we'll get -4/5. So our f of b is -4/5. Again, if you're confused about this, you can always check out my video, which I'll link in the description down below, which specifically goes over average rate of change over set intervals. All right. Now let's go ahead and plug in our numbers to find the average rate of change. Our f of b is -4/5, and our f of a is -1. Our b is -3/4, and our a is -1. Subtracting a negative is the same as adding it. So this is plus, this makes a plus, and this makes a plus. So what is -4/5 plus 1? Well, 1 is the same as 5/5. So -4/5 plus 5/5 is 1/5. And -3/4 plus 4/4, because 1 is the same as 4 over 4, is 1/4. And again, we're going to use this copy dot flip. So we're going to copy this first number, which is 1/5, dot, and flip the second number. If we multiply that, we'll get 4/5. So let me go ahead and rewrite that. 4 over 5. So our average rate of change is 4 over 5, and that corresponds to B. So our correct answer for this question is B. If you're finding this video helpful so far, be sure to leave a like and subscribe. And if you want the PDF file to this exact exam and the answer key so you can do it yourself, join the Discord server, which is linked in the description down below, and you can find it there. So this next question is asking for the inverse of g of x. Remember that to find the inverse, you need to swap x and y. So let's go ahead and just do that real quick. We'll get x equals -3 minus y cubed. We're going to add 3 to both sides. We're going to get x plus 3 equals -y cubed. We're going to divide by -1 to get y as a positive, because we want y to be positive. So we'll get -x minus 3 equals y cubed, or y raised to the third power. And then we're going to take the cube root of both sides to get y by itself. And if we do that, we'll get y equals the cube root of -x minus 3. So that is the inverse of g of x. That was pretty simple, and this corresponds to A. so A will be our answer for this question. Now let's go ahead and do a graphing problem. Um, expect to see a lot of these on your test. A lot of teachers like to throw it on your test because it takes a lot of time to do these questions, and they just throw on like 3 graphs and you have to do all of them. So I'm going to show you how to do these quickly and efficiently so that you don't take ages to solve them. So this is clearly a parabola because our leading x value is 2, or it's x is raised to the second power. So if you're unfamiliar with parabolas, you can check my video on parent functions, which is in the Unit 1 playlist, and I'll link it down below. So the first thing we need to do is find the vertex, obviously. To find the vertex, you need to know negative b over 2a. I feel like that's a general thing you need to know. So this is in the same format of ax squared plus bx plus c. So in this question, our a is 1 and our b is 4. So let's go ahead and plug in 4 for b and 1 for a. We'll get negative 4 over 2, which is negative 2. So our x value for our vertex is at negative 2. Now to find our y value, let's go ahead and plug in negative 2 back in for x and solve for y. If we do that, we'll get y equals negative 2 squared plus 4 times negative 2 minus 5. Negative 2 squared is 4. 4 minus 4 plus 4 times negative 2 is negative 8, and 4 plus negative 8 is then 4 minus 8 minus 5, which is 4 minus 8 is negative 4, and negative 4 minus negative 5 is negative 9. So our y value will be negative 9. So our vertex will be at negative 2 comma negative 9. Okay, so let's go ahead and plot this on a graph so we know what we're dealing with here. I'll just say negative 9 is around here. So this is where our vertex is. Remember that parabolas are in a U shape, so just keep that in mind. Most of the times, teachers require you to plot 2 to 3 points. So we're going to go ahead and find the y-intercept and the vertex, which we already found. Those will be our 2 points. So to find the y-intercept, x is 0. So we'll get y equals 0 squared plus 4 times 0 times 4 times 0 minus 5. 0 squared is 0. 4 times 0 is 0. And 0 minus 5 is negative 5. So our y-intercept will be at 0 comma negative 5. I would say negative 5 is around here. So this is where our y-intercept is. So now that we have our vertex and our y-intercept, we can go ahead and plot this graph. I'll use a different color. I would say let's use red. So we're going to be in the U shape, and we're just going to go through these points like this, something like that. And that is the graph of this parabola. So we have done the first part of graphing f of x. Now let's go ahead and find the following. We know our y-intercept is at negative 2 comma negative 9. I'm sorry. That is our vertex, not our y-intercept. We know our y-intercept is at 0 comma negative 5 because we just solved for that. So let's go ahead and find our x-intercepts. To find the x-intercept, we need to set the to find the x-intercept, we need to set y equal to 0. So we're going to go ahead and use the AC method, which you need to know how to do. So what two numbers multiply to negative 5 and add to 4? Well, 5 times negative 1 multiplies to negative 5, and 5 minus 1 adds to 4. So we'll get x squared plus 5x minus x minus 5 equaling to 0. We'll go ahead and group our terms. Factor out of x, we'll get x plus 5. Factor out a negative 1, and we'll get x plus 5. Make sure these two match up. Then we'll go ahead and group these two into a parentheses. So we'll get x minus 1, and then group these two in a parentheses, and we'll get x plus 5. Set both of these equal to 0. We'll get x equals 1 and negative 5. So our two x-intercepts are at negative 5, comma 0, and 1, comma 0. Now let's go ahead and find the domain and range. The domain for all parabolas is negative infinity. The domain for all parabolas is negative infinity to infinity. And the range is from our lowest y value to our highest y value. Our highest y value is infinity because of these arrows here, and our lowest is negative 9. So our range will be including negative 9 to infinity. Now we need to find how this graph transformed from the original parent function, g of x equaling x squared. So how is this function transformed? This question will normally be a follow-up question they'll ask you on an exam. So if we look at our graph, we can see that it moved over to the left by 2, and we moved down by 9. So our graph transformed, I'm going to go ahead and write it down here. Our graph transformed from the original x squared because x squared starts at 0, 0. So it's basically asking how has our vertex moved is basically what it's asking. So our vertex moved left 2 and it went down 9. Now, if your a value right here is like less than 1 or greater than 1, that means you have a change in it shrinking or stretching. We don't have that here because our a value is 1, so we don't need to include that. So it didn't stretch or shrink at all, which is really nice. So yeah, that is the transformations of this parabola.